Hi everyone, welcome to Vedantu English. I'm Diksha Ma'am, your chemistry master teacher. So everybody, how are you all? How are you all doing? And today we are almost on the completion of chemical kinetics, right? We have done two basic lectures. We have done rate of reaction, order, molecularity, different questions based on that. And today is the most important topic of your chemical kinetics, that is zero order, first order and second order reaction. Okay, so everybody let me know in the chat box if you all are ready for the same, and also let me see that why students have not joined. Right? Are you guys, don't you like marks? Right? Huh? Don't you like gaining marks out of one lecture? Wait a minute. Okay. Yes. Done. So, let me just inform all the students here. Right. Chalo ji. Done, 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 done. So, starting with today's lecture, first thing is, what was your homework last lecture, right? So, if you see, first let me just introduce myself. I am Diksha Ma'am, your chemistry master teacher, and I have 7+ years of experience for NEET and JEE category. And guys, I am BSc, MSc in chemistry and PA. That's my introduction. I think so, right? Now you are absolutely ready to enjoy and learn, right? And there are only few students who actually are serious about like doing homework, right? But I'm so happy to see these students. Future IIT and wonderful, I think this is Ria. Let's grow style. Can you please mention your name also here? I also want to know. It's like I am talking to a company, right? I want to talk to you guys, right? So you can just write down your name also here. Those students who put in efforts to do the homework, right? So future IIT and let's grow. So very good. Then unhuman. Then very good. Shlok, Vishnu, Vishu. Then Harsh. So all these students have done their homework. That's great. That's really good. Right, ma'am, how much time will this session take? See, this session is going to be a little lengthy, maybe 1.5 hours to 2 hours. Okay, let me be very clear on that. Right, so that's why I told you that please have your dinner before the class itself, because otherwise it is going to be very I would say you will miss on your dinner. Or you can, if you have not had your dinner, then you can have dinner in between the class while I'm teaching, right? So nobody is stopping you to eat while in the class. But yes, I would not advise you that. But if you're hungry, then definitely. Now, let us see what are the questions that we had. Right, first question for homework was, which of the following can be order of reaction? So, see, order of reaction can be 0, 1, 2. So, this under root of -5 is not the order of the reaction, right? If you see, this 2 can be the order of the reaction. See, we know that order of the reaction can be negative, positive in fraction. But under root of -5, under root of minus itself is a iota, right? You are like math students, you know that this under root, when you take under root of this, under root of minus, right? That does not even come under integer, right? So that order is not possible in that case. And this is 5 factorial, which will be very large value, 5, 4, 3, 2, 1, right? So that is going to be a very large value. So that's why that is also not possible. So answer is going to be A, that is 2 is the correct answer, right? Next is molecularity of a reaction is equal to order of the reaction in case of which of the following. So in the last lecture, I told you about molecularity and order, and there we learned that in elementary reaction, molecularity is equals to order of the reaction. Okay, so very happy to see the students who have done the homework. Now tell me in the chat box if you are ready for zero order, first order and second order reactions. And these are very important reactions, very important questions are be asked based on these things, right? If you're ready for this, then spam the chat box with green hearts. I also want to see your energy in the chat box, students. Yes, very good. Okay. Okay. In reactions, could you suggest any solution for it, ma'am? VK Sports, you do one thing, you put it in the comment section. You can give the heading that suggestion for a video, because these kind of things I can only teach you in the video form, right? Because these are things how to learn organic chemistry reactions, how to do inorganic chemistry. I need to teach you this full-fledged, right? So I'll definitely make a video on that, right? Okay, I can't see your energies in the chat box. What happened to you, right? Do you hate chemical kinetics? Don't you like chemical? Don't you like topics that give you marks directly, right? What has happened to your energy, guys? I've been seeing that your energy is going down, down, down. Ma'am, I want to see one shot, ma'am. Ma'am, one shot you teach me. Then in the exam, we'll give you one shot here, right? So that's why I'm teaching you in detail, right? So one shot is for revision. It's not for your first time. I'm teaching like fast pace, ma'am. Ma'am, it doesn't matter. I have to just give myself a false hope that I have learned this chapter, right? In reality, whether the concepts are clear or not, ma'am, it doesn't matter. You just teach 1 hour, full chapter done. Ma'am, I'm in first class. Are you in first class, Nora? You're preparing for JEE, so everything will be in detail. So for that, you need to be very consistent. For that, you need to be there in every single lecture, right? That should be there. Okay? Yes. Very good, very good, very good. So let's start the class. Let's start the class. Starting with the zero order reaction. So guys, firstly, we will derive the relations here, right? Okay. So derivation is not important for you, but I am just teaching you so that you know the concept behind this. We are not going to do full-fledged derivation, but you should know the concept behind it, right? So we know that in a zero order reaction, it is that reaction in which rate is equals to, this rate is equals to, I can write it by small r is equals to K. This is A naught initial or you can say just concentration, right, raised to power 0, right? Or I can just write it here, concentration raised to power 0. That is zero order reaction. When the stoichiometry, when the coefficient is raised to power 0, that is called the zero order reaction. Okay. So we know that anything raised to power 0 is nothing but 1 only. So rate will be equals to 1 here, right? So rate is equals to, the rate is equals to rate constant here. That is the first thing, right? Now, from the rate, this is from the rate law equation, right? But if you talk about the differential rate, we know that R is equals to, if I talk about any reaction here, let's say I am talking about this reaction. Let me just write down the reaction. Let's say I am talking about that you have a reaction where A is getting converted to B. If I say this is A naught, this is 0, this is at time is equals to 0, when nothing has happened. At time is equals to T, what will happen? Time is equals to T, this will be A naught minus X, and here X will be formed, right? So because here X is decomposed and that X is getting converted to formation of the product, right? Now here, if I write from the differential rate law, R is equals to minus of dA. Can I just write it dA by dt? Generally, I am writing that this A is getting removed. This A is the reactant. So, from the differential rate law, we know that R is equals to minus dA by dt. And we also know from the rate law expression, R is equals to K, right? Because A raised to power 0 is 1. So, this is our equation that we have formed, right? Now, from this equation, firstly, what you will do here, this is the equation that you have formed here. Now, you will convert this equation. Now, you will convert this equation by integrating it. You take the integration minus dA by dt. This is equals to integration of this is K. We know that what we can do here, this dt we can place here. So it can be minus of dA. This can be integration of kt. Right? So you can also place this minus over here. So this can be your minus of kt. Right? So now integration, this is 1 and this is constant. So you can take it outside. So it will be minus of k This is 1 dot dt. This will be 1 dot dt. Now, bacha, you have also learned about integration, right? In physics, you must have learned about integration, right? And you are JEE aspirant, so I feel that integration will be very, very simple for you guys, right? So, when you have integration of unity, that is nothing but A, right? So, you can say A, this is minus of K, this is nothing but T, because the differentiation, this is dA, so it will be A, this is dt, so this will be T. Now, this integration is from initial to final. Initial was this was your final. So, I can also take that this is also AT, concentration at time t, concentration at time 0. So, I'll take it as initial concentration as A naught, final concentration as T, AT, initial time as 0, final time as T, right? So, when I put the values, first you tell me till here if this is clear to everybody what we are doing here. Till here if that is clear to everybody what we are doing here. Okay, Rama Raju, I'll surely make a video on that soon, right? By next week that will be uploaded, okay? Yes, let me know in the chat box if till here things are clear to you students or not, that we did this is initial, final, x amount is reacted and x amount is formed here. So this is k is equals to r. This is because we know that r is equals to k, a raised to power the order is 0. So anything raised to power 0 is 1, so it will be r is equals to k. And from the differential rate law, we know that this is minus because reactant is getting consumed. So this is minus of dA by dt, right? Now, if you start integrating, you will land up to this page, right? Now, here what you will have, this is AT minus A naught, right? And this will be minus of K. This is T minus 0, initial minus final. Sorry, final minus initial. So, it will be AT minus A naught. This is minus of KT, and this is your first formula, which is very, 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 very important. In some books, it is also mentioned as capital AT minus capital A naught is equals to minus of KT. That is the same thing. The representation is different. In some books, it is also mentioned as RT minus R naught is equals to minus KT. That is also the same thing because they are mentioning the initial by capital R naught, final by capital RT. Right? Now, very important thing now I'm going to do here. Right? These things are very, very important to you. You have no idea. Like these questions are directly asked in your JEE. Right? So, if you see this here, this AT minus A naught, can I just write it as, because if I write the value of AT, can I say AT is nothing but A naught minus A naught minus X, isn't it? So, can I also write it as A naught minus X, and this is minus of A naught minus of KT. So, this will become minus of X is equals to minus of KT, which is nothing but X is equals to KT. So, can I write this as my one of the formulas, right? These formulas are very, very important, right? AT minus A naught is equals to minus of KT, first formula, right? Then X is equals to KT. And what is X here? X is amount of reactant consumed or reacted, right? Or amount of product formed, or you can say amount of reactant decomposed or the amount of product that is formed. That is your X. As you can see, amount of reactant that is used and amount of product that is formed, that is X, which is equals to K into T, right? Okay. Where is integral constant? In these equations in chemistry, we ignore that, okay? In maths, we give full respect to your this plus C that you write there, right? But in chemistry, we ignore that, right? Because that is not beneficial to us, right? Okay? Understood? Yes, everybody? Okay. So, let's see what we are going to do. So, this is going to be the formula. And the formula, other formula that you can write is X is equals to K T. These are the two formulas that you should remember. Now, using these formulas, we are going to derive. Now, first thing is a half order reaction also, right? Then we will solve some questions here. What is half life? When 50% of the reactant is consumed. Okay. So that means I can say that half life is when X is equals to A naught by 2. Right. Initially it was A naught. A naught by 2 it is used up and you are left with A naught by 2. That is your half-life period. When initial concentration is half, when the final concentration is half of the initial concentration, that means we can say that 50% of reaction is done. 50% of the reaction is done. Okay, that is your half-life period. Now, how you got this value is by, if you put all these values here, we know that X is equals to KT. If you put this value, X is equals to KT. X is nothing but the amount that is consumed or the amount that is left. So that is A naught by 2. K and T is T half, because half of the concentration, because 50% is consumed. When 50% is consumed, that is called as T half. Okay. So that will be T half, right? So can I just write it here that T half is nothing but A naught by 2K. And from here, right, who will tell me that is the T half dependent on the initial concentration or not? T half is dependent on the initial concentration or not. Subha, if you have any recommendations regarding the queries that you have, the topics that you want me to make video on, then you can definitely write it down in the comment section. I'll definitely check that. Okay, right? Okay, I promise I'll check that. Okay, yes everyone. Okay, so this is A naught by 2K is equals to T half, right? Now, can I say that T half is directly proportional to A naught? I know here it is capital A naught, ma'am, small, it's just the representation is different. Okay, you can also write it the same way, right? So I can also delete it if you want me to delete it. I can also delete it so that the confusion that you are having, that should not be there. So now can I write this thing here that T half is directly proportional to A naught for zero order reaction? Can I say that? Yes, everybody. Now, do you want me to write a general formula just the same way we wrote general formula for units of rate constant, right? In terms of order of reaction. So what is the general formula here? That T half is directly proportional to A naught raised to power 1 minus N. Because here N is 0, so it will be A raised to power 1, that is directly proportional to the initial concentration. Okay, right everybody? Understood? Right? Perfect. Shall I move ahead? Till here, if you have any problem in the formulas that we have discussed here, right? In the formulas that we have discussed here, these are the formulas that you need to learn. This formula should be on your tip. AT minus A naught is equals to minus KT, X is equals to KT, and T half is equals to A naught by 2K. These are the three formulas to learn from your zero order reaction. That should be on your tip. You are sleeping. Somebody is like, okay, tell me the reaction. You're like, okay, AT minus A naught is equals to minus KT. What is the half-life period? What is the half-life time for this zero order reaction? T half is equals to A naught by 2K. Okay, X is equals to the decomposition, the amount that is decomposed or the amount that is formed is equals to what? X is equals to KT. It should be like in your brain like that. Okay. Now, let's do the question. I want to do questions, but okay, let's do the graphs, right? Let's do the graphs. Or do you want to do the questions first? So let's do the graph first. Okay, let's do the graphs. Okay, graphs. Those who have not watched my video of a non-linear and linear graph, please go and watch it, right? But for now, right, let me introduce you this one thing, that y is equals to mx plus c. This is the graph of straight line where y is y-axis, x is x-axis, right? And m is the slope, c is the intercept, right? Slope is the angle that it is making with x-axis, and intercept is, if this is x, this is y, this is x. Intercept is that line is touching the y-axis at which point? At this point, this will be the intercept. If it is touching at this point, this will be the intercept. Okay. The line, the straight line is touching the y-axis at that point. That is called the intercept. Okay. In a conclusion way, I have told you that. But if you're still confused about the graphs of linear, non-linear graphs, then students, I have already made a video on log, anti-log graphs, linear graphs, non-linear graphs, right? Please go and watch that video also after this lecture, because questions of chemical kinetics, electrochemistry, equilibrium, thermodynamics, you need all these things. Okay? Understood? Right, everybody? A part of zero dependent on initial concentration or not. Okay. See, T half means when the initial concentration, when the final concentration is half of initial. So if I say this is, let's say this is A and this is your product B, right? So I am saying initially it will be A naught. So I'll just write it like this here, right? Let's say this is your A, this is B. Initially it is nothing but it is A naught, okay? And this is 0. Now I am saying that your product is half of initial concentration after time t, so this will be A naught by 2. And here you have consumed A naught by 2. So what I told you here, if you can see that, I told you X amount will be taken out, X amount will be formed. So can you see that X amount is nothing but this? That X amount is nothing but A naught by 2. So we can say that X is equals to A naught by 2, and we know this formula that X is equals to KT. You put the value of X here, right? T will be T half, and this will be the formula that you will get. That means T half is directly proportional to A naught, right? And this is the general formula that I have written for you. This is the general formula for any order, right? Oh, ma'am, why this happens with you always? Why? No issues. So I can write it as T half is directly proportional to A naught, and T half is directly proportional to A naught 1 minus N. This is for zero order reaction, and this is the general formula. So you can write here, this is the general relation. General relation. Okay, understood? Right? Right, Bhardvaja, ready? Is that clear now? Santoshi ji, don't spam, huh? Don't spam. I can see everything that you're writing. You can't understand because you don't want to understand, right? Okay? So don't play these kind of stupid games here, right? Focus on studies. If you're not interested, then you can leave, right? Okay? Yes. So let's do the graphs here. Let's do the graphs here. If you see the graphs, right? Now, first two graphs are, this is time and this is rate. Okay? And this is concentration and this is rate. Now you have to see how these are dependent on each other. See, in a zero order reaction, rate is only dependent on rate constant. It is not dependent on anything else. So rate is definitely independent of the initial concentration here, because it is A raised to power 0, that is nothing but 1. So can I write that rate with the concentration is no dependence. The concentration is increasing, but rate is constant here, right? So you can write here, this means that rate is constant. Rate is, you can say, independent of concentration, is independent of concentration. Rate of a zero order reaction does not depend upon the concentration. That's why straight line parallel to x-axis you have. Here, rate with time, there is no relation of rate with time. As you can see, rate is only dependent on rate constant here. So rate is also constant with respect to time, because with the time, no concentration, with time concentration will change, and concentration change is not affecting zero order reaction. So that's why there is no, it's not like, it's like, bro, I don't care about you, right? So rate be like, bro, I don't care about you, I don't care about zero order, I don't care about time, I don't care about concentration, I am only in love with rate constant, that's it. Okay, that's about zero order reaction, right? Now this is the formula. Everybody see this very carefully. If I want to make a graph between A naught minus AT and T, now see this. What is the formula? What is the formula that you had? AT minus A naught is equals to minus KT. Can I also write it as, if you take the minus here, can I also write it as A naught minus AT is equals to KT? Right? If I want to represent this as Y and this as X, then this will be my slope, and intercept will be 0 here because there is no plus of 0, plus of C, there is no intercept. If you compare this with Y is equals to mx plus C, intercept will be equals to 0, right? So slope will be equals to positive of K. Slope will be equals to K, and positive slope means the graph will be like this. Okay, so that's why the graph is like this. Intercept 0 means it is starting from origin. That means that's why it is starting from here, right? Okay, and why it is a straight line? Because it is making an equation of y is equals to mx plus c, right? Everybody, okay, clear to everyone? Now let's talk about this graph. If they ask you to make a graph between AT and T, now you have to compare. You just need to pick out your equation, that is AT minus A naught is equals to minus of KT. Now AT and T, that means AT is equals to A naught. You can put it like this also, minus of KT plus A naught. Isn't it? Minus of KT plus A naught. I am just rearranging that statement here, right? So that statement is rearranged at AT is equals to minus of KT plus A naught, right? Now you have to compare this. Y is AT, so this will be Y. X is time, so it will be Y is equals to mx plus C. Can you see this here? Slope is minus of K and intercept is A naught. That means the point where this line is touching y-axis is A naught. And this point is this particular, so here it is nothing but this point is A naught, because intercept is A naught, right? And why this slope, this is going down, why this is not like this, why it is not like this, why it is like this? Because slope is minus of K, slope is negative, that means it will go downwards like this, right? And that's why you have this particular graph for AT and T. Is that clear to everybody? Right? Okay. Ma'am, how can you tell it is independent? Initial, right? Because more initial, more the T half. No, it is not dependent on the concentration. That is what zero order reaction is. Zero order reaction is not dependent upon the concentration. Okay? T half is dependent on the initial concentration. But the overall reaction is not dependent on the concentration. Okay? Overall reaction is independent of the concentration. T half is dependent on the initial concentration. And that too only initial concentration. T half is not dependent on final concentration or anything. Only the initial concentration. Okay? Yes? Now, next is X is equals to KT. Have we defined this already? We have already used this formula, right? So we can say X is equals to KT. So this is Y is equals to, this is mx plus C, where we can say intercept is coming out to be 0, slope is coming out to be K. So the graph will be starting from origin and it is a straight line with slope is equals to K. Positive slope, so it will be upwards. Now let us see alpha, that is degree of dissociation. Now who will tell me the value of alpha here? Who will tell me the value of alpha? What is degree of dissociation? Yes, students, what is degree of dissociation? Degree of dissociation is nothing but, you talk is about alpha, right? It is the number of moles that is dissociated, that is X, by initial concentration, right? Number of moles that is dissociated, that is X, by initial concentration, that is alpha. We know that X is equals to KT. Now X is nothing but, if you see, I'll just put the value also here. Yes, you can also do it like this. If you divide all of them by A naught, right? This X by A naught is nothing but alpha, so this will become KT by A naught. That will be the formula that is already written here. Okay, everyone? Alpha is the degree of dissociation. That is nothing but the amount that is dissociated, right? So that is number of moles. What is the value of dissociation? What is the value of alpha, right? So I'll just write the value of alpha here. Alpha is nothing, the formula is number of moles dissociated divided by initial moles. Initial moles. If you see this formula here, number of moles dissociated is nothing but X amount is dissociated, initial is A naught, so that's why alpha is equals to X by A naught. Right, everybody? Okay, is that clear? Till here, any problem? Okay, till here you have any problem, then let me know, right? So, now you need to compare it with the straight line graph. That is alpha and E naught by K. What is the value of alpha? Acha, nahi. Alpha and T. This is X, Y axis is alpha and X axis is T. So this is Y, this is X, right? So can I say Y is equals to mx plus c? Slope is equals to which thing here? Slope is nothing but K by A naught. Can you see? When you compare this with Y is equals to mx plus c, m is the slope, that is coming out to be K by A naught, and intercept is 0, so that's why it is starting from 0, and slope we have written as K by A naught here, because slope is positive, so that's why the direction of the graph is upwards. Right, everyone? That was about the graph of zero order reaction. We have done 1, 2, 3, 4, 5, 6 graphs we have done, and all the graphs are very, very important for zero order reaction. If you have any problem in the graphs, then let me know in the chat box. Right? Okay? Yes, everybody, if you have any problem in the graphs, then let me know. And now let's do some questions based on zero order reaction. Okay, Ji? Let's see the first question here, that is the decomposition of NH3 on platinum surface. Decomposition of NH3 means what? Decomposition of NH3 means you are decomposing it. This is converting to N2 plus H2. This will be 2, this will be 3, and that will be done. Decomposition on platinum surface is zero order reaction. What are the rates of production of N2 and H2 if K is equals to this, right? If K is equals to 2.5 into 10 raised to power minus 4 per mole liter per second, then what is the value here? The decomposition of NH3 is this. What are the rates of production of N2 and H2 if K is this? They are saying that it is a zero order reaction, right? Rate of production, if K is given to you, K is given to be this thing, right? It is a zero order reaction. That means, can I say that AT minus A naught is equals to minus of KT? The first thing. And I also know that X is equals to KT. These are the two things that we already know, right? And we also know that in a zero order reaction, R is equals to K. That means rate of reaction is equals to K. Rate of reaction. These are the three things that we have learned in a zero order reaction regarding rates, right? Now they have given us rate constant. That means rate is also equals to 2.5 into 10 raised to power minus 4. Okay. Now, if you see this here, this is already given. But what I need to find out is decomposition of this on this. What are the rates of production of NH2 in this? See, we know that R is equals to, in the differential rate law, what we have learned, that R is equals to reactant minus 1 by, because reactant is getting decomposed, so it will be minus divided by the stoichiometry and dNH3 by dt, right, equals to, right, then you have positive of a dN2 by dt equals to positive of, because it is appearing, things that are appearing is positive, right? So it is 1 by 3 dH2 by dt, right? Now tell me one thing, they are asking you to find out the value of rate of production, rate of appearance. This thing, this is rate of appearance of N2, and this is rate of appearance of H2. Can I say this? This is rate of appearance of N2, this is rate of appearance of H2. This, if you're not sure what I'm teaching you here, then I have taught you this in lecture 1 of chemical kinetics. You can go and watch that, right? Now students, if you see this, we are clear with. But now what you have to see, I'll just see if I have next page, which we don't have. So what I'll do, right? I'll solve it here only with this thing, right? Now rate, can I say that? Where should I write it? Chalo. I need to use this na. Chalo, I'll do this thing. I'll erase everything here, right? Okay. So d of N2 by dt is equals to R. I can write d of N2 by dt is equals to R, which is nothing but equals to K, which is 2.5 into 10 raised to power minus 4. So that is clear. d of H2 by dt is equals to, in comparison to rate, this will be equals to 3 into rate, because this 3 will move here and this will be 3 into rate, right? So can I write that this is 3R, that is nothing but 2.5 into 10 raised to power minus 4 multiplied by 3 will be your correct answer here, and that is going to be the answer that you will have, right? Okay, everybody, clear? Right? Very good. Rate of production of N2 will be this, and rate of production of H2 will be 3 into rate. Okay? Now, next question is, students, let's do the next question here. That is, the rate constant of reaction, this is this. Okay. There is some reaction. The rate constant is given to you. Okay. So, I'll just write it here. Rate constant of some reaction is given here. A give rise to B. They are saying rate constant of the reaction is this. That means K is given to you. K is given to you. Now, can you see here, they have not mentioned that whether it's a zero order reaction, it's a first, it's a second order reaction. But one thing you have learned, that the units of K are mole per liter, 1 minus n per second. This you have learned. Okay. So, if I want to have mole per liter per second, then n should be equals to 0. Only then I'll have mole per liter per second. That means from the units we are predicting that it's a zero order reaction. So we can say that from the units it's a zero order reaction, right? That means the formulas of zero order reaction will be applied here. If the rate constant is given to you, the concentration of A is 5, then concentration of B, okay, if the concentration of A is 5 molar, after 20 minutes, they are asking you what is the concentration. Okay. So we know 2-3 things here. We know that rate is equals to K only in this first thing, right? We also know that X is equals to KT, right? We also know that AT minus A naught is equals to minus of KT. right? K is given to you. T is given to be 20 minutes. Then the concentration of B after 20 minutes. Then what you have to do with this A? Concentration of B after 20 minutes. Okay, let's do this. Right? This is T is equals to 0. This is given to be A naught. This is 0. Okay. T is equals to 20 minutes. Let's say this is A naught minus X and this is X. Now he is asking you to find the value of X here. Right? That what is the concentration of B after 20 minutes. Right? So that is very easy. Acha. X is equals to nothing but K into T. So K will be nothing but 0.6 into 10 raised to power minus 3. Right? Multiplied by T is nothing but 20. Right? And one thing you should need to be clear that this is given in 20 minutes. Right? And this was given in K is given in this. So the concentration, if you are finding out K into T, right? Solve this in the format of seconds only. So this will be into 60 and you will get your answer here. Right? Okay, everybody. That's how you need to solve it. Got it? Okay, very good, Bhardwaj. Bharat, very good, Riya, very good, Ramaraju. Very good. Okay, Ramaraju, I'll ask the team to add it. Okay. Yes. T should be taken in seconds. Very good, very good. T should be taken in seconds. Yes. Okay, that's why we multiplied it with 60. Right? Okay. Yes. Now, let's see a JEE Mains 2025 question based on this. JEE Mains 2025 question based on this. Let's see this and let's see who is going to solve this question here. Okay, who will solve this? So the question goes like this: half-life of zero order reaction is 1 hour. Okay, T half is given to you, that is 1 hour. When initial concentration of reactant is 2, initial concentration is given to be 2. That means A naught is given to be 2. Time required to decrease concentration of A from this to this is what? Okay. See, first thing is they have given you T half. Whenever T half is given to you, use the formula. T half is equals to A naught by 2K. Right? Now, students, see, A naught is given to you. They are saying the initial concentration is this. So, it is 2. Right? And 2, this is K. T half is given to be 1 hour. And here the answer is also in hours. Okay, minutes also it is given. Let's solve this in hours. Okay, so if I put it this 1 only, then answer will be K is equals to 1. That is the rate constant that you have, right? If you solve this in minutes, that will be K is equals to 60 per minute. Okay, mole per liter per minute. That will be the answer. Now I have taken this in minute, this in hours. Okay, in second things will be different, right? This is basically 1. This is basically nothing but this is K is equals to 1 per minute. You can say mole per liter per hour. It's like this. Okay. Now, what I have is the time required. We know that AT minus A naught is equals to minus KT. Now they are saying time required to decrease concentration of 0.5 minus 0.25 minus of Kt. K is given to be 1 here. T is what you have to find. So T will be equals to what? Wait a minute. AT minus of Kt. This is minus of T. T half is given to be this. AT finally decrease the concentration from this to this. Acha, my bad. They are saying from this. This is the initial concentration in that time and this is the final. Don't say, ma'am, why you are not putting A naught is equals to 0. This is for a specific time. They are saying from this to this. That means for that time, I can say This is A final minus A initial, right? So this is your A initial and this is A final. This is A final, right? So A final is nothing but 0.25. This is 0.5. And when you replace this, this will be 0.5 minus 0.25, right? And the answer will be 0.5 minus 0.25 and divided by 1, right? That is going to be your time here, right? Solve this, that will be in hours, right? That will be in hours, right? This answer is going to be in hours. Then you need to see and convert it into minutes or something. Now, bacha, tell me, who will tell me the answer here? Who will tell me the answer here? Who will tell me the answer here? Very good. 6 minute, 15 minute, 6 minute. Why you have added specified that, right? Why you have specified 0.25 hour, right? Okay, 0.25 hour, that is not mentioned here, right? So you need to convert it into minutes. So for minutes, you will multiply this with 60, right? Okay, then you will get your answer here, right? 25 divided by 100, that is nothing but 4, 2, 2, 2, 3, and that is going to be your 15 minutes, right? 15 minutes is going to be the correct answer here. Okay, students. Yes, everybody clear that option B, ma'am. Very good, very good, very good. So that was your question and that's how you solved your answer. That is 15 minutes. Okay, because the answer was given in both hours and minutes. That's why firstly I answered it in hours so that we can convert it into minutes, right? But if you solve all together in minutes and then you will get confused, then the chances of doing silly mistake will be more, right? Okay. Now, let's talk about the next reaction, that is first order reaction. So everybody, all of you, are you ready for first order reaction? And one more thing before going here, before going one more thing. See, if you see this is, let's say initial is A naught. After T half, it will be A naught by 2. And in zero order reaction, after one more T half, it will be like 2 times. When you have 2 times of this will be completely consumed. Completely consumed. After 2 half-lives. That means in zero order reaction, T 100% is equals to 2T half. Okay, that is a very, very important point. Now you might feel like, ma'am, what's the big deal in this? But in first order reaction, things are different. That's why this becomes very important for you. That in T half, right, in zero order reaction, if initial concentration is A naught, after T half, let's say T half is 60 minutes. Okay, let's say T half is 20 minutes. T half is equals to 20 minutes. Then the reaction will be completed. Reaction will be done in 40 minutes. In 40 minutes, the full reaction will be completed. Okay, right, everybody? Now, can you tell me all the examples of zero order reaction? Who will tell me the examples of zero order reaction? Can you tell me the examples of zero order reaction? Any one of you who can tell me before moving towards the first order reaction? Can you tell me the examples of zero order reaction? So let's see that. What are the examples of zero order reaction? Examples are like first is you have first is, for example, I am talking about, let's say, photo. These are some of the examples, right? Otherwise, there are so many examples. Photochemical reactions where you use light, right? Where you use light, that is called photochemical reaction. Okay. Yes, everybody. Okay. Yes. Now, Let's see. Hello, hello, hello. Just Abhishek. Hello. So, second is, let's talk about enzyme-based reactions. Okay, what are enzymes? Enzymes are what we use in like in our body. We don't use, our body use it, right? So you have different enzymes, maltase, invertase, okay, all these enzymes that bio students are more aware of, right? So in our body, see, in labs we use catalyst. In our body, the biological catalyst we have that is given by nature, that is enzymes. In all the reactions that have enzymes, right, they are your zero order reactions. Third is, if you talk about photo, then you talk about surface, surface reactions. For example, you are using platinum or any catalyst you are using on the surface. It is happening by adsorption of some chemical on the surface. That is your zero order reaction. Here I have just given you examples of zero order reaction because what happens in the exam, sometimes they don't mention zero order reaction. They will give you some examples that are very famous. So these are one of the famous examples, some of the famous examples of zero order reaction. Okay. Yes, very good, Hema. Decomposition of ammonia in a hot platinum surface is a zero order reaction. Very good, Hema. Very good. Okay. So, next thing, let us see. Everybody, yes. Okay. Very good. Hydrolysis of sucrose. Very good. Very good. Okay. So, shall we start with first order reaction now, everybody? Are you like completely now, do you have confidence that you can solve the questions of zero order reaction, right? Today I would want you, I have given you enough time to practice zero order, first order, second order reaction. Well, basically zero and first order reaction is asked maximum. Second order reaction, like 0.001% will be asked, but you should know the formula, right? So we will do first order reaction in the same amount of time, right? It is more in detail we will do, and after that your class will be over, right? Okay. Okay, Ji. Yes. Now let's see this first order reaction. Like everybody spam the chat box with green hearts. Every student that is sitting here and who thinks that ma'am is making some efforts, you are learning something out of this class, then I want you guys to spam not stupid things but green hearts in the chat box, and let's rise the energy of this class. Okay? Yes, everybody. Yes, everybody. Let's increase the energy of the class. Let's not spam. Let's be together. Let's learn. Let's make ourselves successful, right? Because all of these things will matter in the end, right? Okay. Yes, everyone. Great. Okay, perfect. So now let's see first order reaction. In first order reaction, guys, if you see this, right? Firstly, I will derive it, okay? Firstly, I'll derive it for you. So let's see what we are going to do here. So everyone see this. You have A. This is, let's say this is A. And this is B. Initially, you have A naught. And initially, this is 0. No product is there at time is equals to 0. At time is equals to t, what has happened here? A naught minus X amount is consumed, X amount is formed here in the same amount, right? Okay. And this also, this I am saying that AT is the concentration at time t, which is equals to A naught minus X. And this is X amount is used up here. And X amount is formed here, right? Same that we did for the zero order reaction. But here, they are saying that from the rate law expression, we know that R is equals to K A, that is the concentration raised to power 1. Because it's a zero order reaction. Sorry, it's a first order reaction. So here it will be 1. And we also know that according to differential rate equation, this is minus of dA by dt, right? Now, from these two things, we will solve this. So, we can also write it as k into t, and this a we can take it here. This will be, this minus I can take it here. Guys, you are like maths students. I know these things are very, very like easy for you guys, right? For NEET aspirants, I focus on these things more, but I know that you are like pro in all these things, right? Because you are like integration, differentiation is not a big deal for you, right? Now do the, yes, this will be dt, will come to this side, so it will be dt, right? Now you need to integrate. For integration, take constants outside, right? This will be there, right? Now when you solve this, this will be minus of k t minus 0, because if you have a unit here, right? Like you have, wait a minute, you don't have, this is just dt, right? This is 1 dot dt, because when you have a unity here, right? Unity, differentiation, then integration is nothing but t only, right? And we know that this is nothing but the initial time is 0 and final is t. Initial concentration is A naught and final is AT. So that's why we are writing it like this. This is t minus 0 and this is the, array, mistake I have done here, wait a minute. This will be equals to, this A will come to this side, so it will be integration of dA, this is 1 by A. Now who will tell me what is the integration of 1 by A dA? 1 by A dA, what is the integration, guys? Integration is nothing but this is ln of A. And here the value is from 0 to, value is from A naught to AT. Right? So this is A naught and this is AT. Okay? That you have to know. Now, in the form of this, I'll just solve this. This will be minus of KT is equals to ln of AT minus ln of A naught. That is the first formula of first order reaction. And first order reaction has a lot of formulas, okay? The way of writing the formulas is different. Now, this is in the form of natural log. Okay, this is in the form of natural log. When you convert natural log to which thing? Everybody? When you convert natural log to log base 10, what will be the answer? That will be minus of KT. This is multiplied by 2.303. So you can divide it here. This will be log of 80 minus log of A naught. That is the second formula. Right? Can I just write all these formulas here? Can I just write it here? Ln of 80 minus ln of A naught is equals to minus of KT. You can also write it as ln of A naught minus ln of AT. Ln of AT, if you place minus here, it will be is equals to KT. If you multiply all of this with minus, this will be ln of AT minus ln of A naught is equals to minus of KT. If you multiply this with minus and this with minus, this will become KT. This will become ln of A naught minus AT. You can use these two formulas, right? You can also write it in the form of log of A naught minus log of AT. If you convert natural log to log base 10, this will be multiplied by 2.303. You multiply this by 2.303, that will be in the division here. So here you can also write it in the form that will be equals to KT by 2.303, which is a very important formula. You have no idea how important this formula is. Now students, in log, anti-log, the basic lecture I have also taught you that log m minus log of n is nothing but log of m by n, or you can, I'll just write it here. Where should I write? I am writing the property here. Log of m minus log of n is nothing but log of m by n. From this property, I am also writing one more thing, that is log of A naught by AT, initial by final, is equals to KT divided by 2.303. if you write this also the same way, you can also write this as ln of a naught by at is equals to kt. And these are the formulas that we have here. Okay, everybody? Everybody, is that clear? Very, out of this, the most important formula in numericals is this one. Most important formula. Right? Okay? Most important formula is this one. Log of a naught by at is equals to kt by 2.303. That is the most important formula for you. Okay? Okay, everybody? Bharat, what to do? What to do? That's why I always tell my students that join the batch, right? We have Sigma batch that is going on. There no spammers can join, right? Because they don't have the facility to join there. They'll have to pay to join that, and the payment is also 3,999, right? The dedicated student will pay for that, right? So that's why batches are different from YouTube, right? Because of these spammers. Otherwise, students are always hardworking. The teacher also wants to teach, right? But these people makes it very difficult for the teacher to teach, for the students to learn, isn't it? Yes. Okay. Is that clear, students? Shall I move ahead now? Now, that is your first order reaction. This is one of the formula that we have written here, right? But chal. Okay. Now, let's talk about T half here. Let's talk about T half, right? Let's talk about T half. If you see T half here, what is T half? Everyone write it down in the chat box. What was T half? What was T half? T half was when the x is equals to a naught by t, right? Now we know this formula that we can say that log of a naught by at is equals to k t by 2.303. Okay. Now, if I am saying that how much amount is consumed and how much of the product is left, then can I say that AT is nothing but A naught minus X, and A naught X is nothing but A naught by 2. This should be 2 here. Okay, this should be 2 here, right? So I'm just writing it there. Okay, this should be 2 here. So I'm just writing it here. This should be 2.303. Okay, this would be 80 by 2. Okay, so if I write it here, that will become nothing but A naught by 2. Okay, now X is nothing but half of the concentration you have consumed, and you are left with half of the concentration, and AT is nothing but A naught by 2, and X is also A naught by 2. So can I just put it here? If you put it here, this is log A naught, this is A naught by 2, this will cancel, and this will be K, this will be T half, this will be 2.303. If you once you solve this here, what is the value that you will get is, this will be log base 10 of 2 is equals to K, this is T half, this is 2.303. And log base 10 of 2 is nothing but, it is nothing but 0.301, right, equals to, this is divided by K, this is T half. And after solving, the value you will get is T half is equals to, after solving this will be 0.693 divided by K, and that will be your final value. And that is going to be the final value here. So you are going to write T half is equals to 0.693 divided by K is going to be the final value of T half here. Now, can you see one thing, that T half is independent of A naught. T half is not dependent on A naught. 1 minus n, if you put the value of n as 1, that will become A naught raised to power 0, and that is nothing but independent. Right? Students, is that clear? T half determination. Okay? If that is clear, then let me know. Let us see how many likes you have given to this class. I don't expect that much from you guys because you guys are not talking. Nothing is there. Na, I am teaching myself or what? So let's see this here. I asked you to make the likes by 50 plus before the class. Even now it's not 50 plus. It should have been 100 plus by now. Right? What you guys are doing here? Not sharing my content with anyone, not sharing on WhatsApp, on Instagram, nowhere you are sharing. Then one day ma'am will stop teaching and then you will search for ma'am. Trust me on that. Right? Because even we need appreciation. We are humans. Right? Okay? So you need to tell word of mouth is big thing. So tell, appreciate us as well. What if you cleared your AIR 1, you are like JEE cleared your like JEE advanced with AIR 1, but the colleges are like, we will not give you admission. You'll be like, why the hell I studied so much for that, right? So we all need it, right? So let's talk about the graph here. Second is the graph, okay? So if you talk about the graph, we know that rate is equals to K into A. That is your rate law expression. So if you compare rate with A, we know that Y is equals to mx plus C. Here intercept is 0 and slope is equals to K, which is a positive slope. That's why, and intercept is 0. That's why it is starting from 0, right? It is starting from 0 and it is a positive slope. That's why it is going like this, right? Okay. Next thing is, have we learned about this concept? Have we learned this formula? We have learned log of A naught by AT is equals to KT by 2.303. If 2.303 is here, 2.303, and this K or T is mentioned here, so this will be the same thing, 2.03 by K by T log A naught by AT. Now they are asking you to find a relation between log of A naught by AT and T. So let's do this. Log of A naught by AT is equals to K by 2.303 and this is T. Now this is the formula. Now we will compare this with Y is equals to mx plus C. This is Y, this is Y. So can I write Y is equals to this is X. So this will be your M here plus C where C is going to be 0. And slope is positive. That's why it is inclining upwards, right? That is slope is K by 2.303. Because intercept is 0, that's why it is starting from the origin here, right? That's why it is starting from the origin. Okay, right everybody? Got it? Clear? Perfect. That's great. If Insta is deactivated, that's brilliant, right? But you can share this on your WhatsApp, right? You can share this with your friends, isn't it? So let's talk about this graph here. They are asking you to find a graph between ln of A naught by AT and T. So beta, you just need to know the formulas here. If you know the formulas are ln of A naught by AT equals to KT. If I compare this with Y is equals to, this is Y is equals to, this is X, this is M plus C. So can I say that here intercept is 0, slope is equals to positive, that is K. So that's why slope we have written positive, it is inclining upwards because it's positive. And here it is starting from origin because intercept is 0 in this case. Okay? Intercept is 0 in this case. Now let's talk about the next, which is you have to find a graph. They will ask you the graph between this and this has slope value, this value they will give you. For that you should know what is the value of the slope, right? That's how the questions are asked in the exam, right? So this is ln of AT and T. So if you compare this, we know that ln of A naught by AT is equals to KT. We can also write it as ln of A naught minus ln of AT is equals to KT. Now ln of AT should be your X. So can I write it as ln of AT is equals to ln of A naught. You're like, ma'am, I don't know why you're talking about our x's, right? What to do in maths and physics and chemistry? Everyone is talking about x's, right? So what to do? But I'm not talking about your x, I'm talking about this x. Okay, you need to focus here. It's not like, ma'am, I went into my own, ma'am, dreams, right? Focus here. So this is y is equals to, this is x, right? This is y, right? Right? Some students are like, ma'am, yes, ma'am, why x? Why you did this to me? Why x? Right? Control your feelings, right? So this is y is equals to mx. This is m. This is c. So can I just compare this? I'll just write it in this way as well. So this becomes ln of AT is equals to minus KT plus ln of A naught. I have just rearranged it so that I can teach you better here. Y is equals to, this is x. So this will be m. This is c. So here intercept is c, right? That is ln of A naught. That's why the point where this is touching y-axis is ln of A naught. Why the slope is declining here? Because it is slope is minus of k. This is the slope. Slope is negative, so that's why it is declining here, right? That's why you have this particular graph here, right? Okay. Very good. Very good. That's great. I'm happy for you. So next is ln of, it's not ln, it's log of AT and T. Okay, now you have to find a graph between this. Now the same equation you have to solve. This beta we have already solved. This is ln of log of A naught by AT is equals to KT by 2.303. If you solve this, this can become log of A naught minus log of AT. You have to find log of AT here. That should be positive, so we can just replace it. This will be log of AT is equals to, this will be log of A naught minus KT by 2.303. Isn't it? Isn't it? That's the same thing. Log of AT is equals to log of A naught minus KT by 2.303. So when you compare this, this is your y. They are saying x is t, so this is x. So the thing that is multiplied by x is your m. So this whole thing will be your m, that is slope. And the thing that is added here, that is called intercept, that is c. So intercept, where it is touching the y-axis, is log base 10 of A naught, right? And the slope is negative because that's why it is declining here. Slope is minus k by 2.303. Comparing it with y is equals to mx plus c, right? Okay, everybody, right? Now, last 2-3 graphs, this graph, and this graph is going to be quite challenging for you. So I would advise you to please focus here, right? Okay, see this. We know that ln of A naught by AT is equals to KT, right? Okay. If you solve it the reverse, how you solved it? You know that ln of A naught minus ln of AT is equals to KT. Can I also write it as ln of AT minus ln of A naught is equals to minus of KT? Because we need to find the value of AT here. So I want to have AT here. I want to have AT by A naught. That's how I can solve it. So I can also write it as ln of AT by A naught is equals to minus of KT. Now natural log and exponential is inverse of each other. They are opposites of each other, right? So when you will take exponential of all of this, exponential of ln AT by A naught, right? This is exponential of minus KT. This and this will cancel out. It will become AT is equals to A naught e raised to power minus KT. And that will be your final equation. And this is also a very, very important formula, right? Okay, and that is also a very, very important formula. Is that clear to everybody or not? Is that clear, students? So here you have AT is equals to A naught e raised to power minus KT. Ma'am, what to do? They are asking the relation between AT and T in exponential way. Okay, AT and T. AT and T you have to find out, right? AT was here in the natural log, so that's why I have to make it like this. Now, whenever you have this kind of equation, when you have exponential raised to power this, it will be either like this or it will be either like this. That is exponential growth, right? Exponential growth means uh, uh, x is increasing less, but y is increasing to a very high level. As you can see here, x is increasing less, but y is decreasing to a very high level. Now, one is your increasing exponentially, one is decreasing exponentially. Increasing exponentially will be like this, decreasing exponentially will be like this. Now, why it is decreasing? Because here it is e raised to power minus of kt. So, that's why we are drawing this graph here. That is the graph for exponentials. Okay? Yes, everybody. That is the graph for exponential. Is the graph for exponentials clear to everybody or not? Right? Okay? Array, please tell me if that is clear, beta. I don't have any such magical powers where I can see what is going on in your heart. Trust me, right? I don't have these powers. You think that teacher is God, but teacher is not a God, right? Teacher needs to see whether the students are able to understand or not. For that, you have to commute with me. You have to, communicate with me, right? Okay. Yes. Okay. Now, if you see this here, this is x. So when you draw the graph of, this is also the equation, right? This we can see from here only. This is AT by AT is equals to A naught e raised to power minus KT. So it will be AT is equals to A naught e raised to power minus of KT. Now, we know that x is nothing but AT is equals to A naught minus x, right? So x is nothing but A naught minus AT, right? X is nothing but A naught minus AT. If you put the value of x here, let's see, we know that AT is equals to A naught minus x. Okay, you need to put the value of AT here, put the value here, it will be A naught minus x is equals to A naught e raised to power minus of KT. You solve this, what you will get, x will be here, this will be A naught minus A naught e raised to power minus of KT. Take A naught common, this will be 1 minus e raised to power minus of KT, and this is x. And that will be your answer here. And that will be your answer here. That is x is equals to that is x is equals to A naught. This is A naught bracket 1 minus e raised to power minus KT. Okay. Yes, everyone. Right. Now you have to solve this. Right. Now see, you have to understand one thing. Okay. One thing you have to understand. Why it is increasing exponential graph. See this thing here. See this thing here. We are comparing time with x. Time, like with increment of time, it will increase or decrease. Right? Okay. See this. What is happening here? When time is increasing, when this is increasing, this value is decreasing. So this whole value will be increasing. So this whole value will be decreasing. If this is increasing, then this will be decreasing. Right? Okay. Wait a minute. Wait a minute. If this time is increasing, then this whole value will start increasing. This whole value, time is increasing, this whole value is decreasing. Yes. When the time is increasing, see one thing, if time is increasing, right, this whole value is decreasing. If time is increasing, e raised to power minus kt is also, minus of kt is decreasing. Because that is negative, this is positive. Time increases, the more the value of time, lesser will the value of minus kt. If this decreases, this whole will decrease. Then this whole thing, if this thing is decreasing, let's say a simple thing is you have 1 minus 5 is equals to 4. 1 minus, sorry, 10 minus 5 is equals to 5. 10 minus 6 is equals to 4. So when the subtraction value increases, the answer decreases. When the subtraction value decreases, the answer increases. In the same case, if the subtraction value is decreasing, this whole value will increase, right? So that's why as time increases, x will increase. So that's why it is a positive exponential here, right? That's why it is a positive exponential here, right? But if you see this thing here, it is not the same. If this is increasing, this whole minus of kt will decrease. That means this will also decrease. If this decreases, that is directly proportional, so this also decreases. So as time increases, at decreases. But in this case, it is opposite. As time increases, x will decrease. Sorry, x will increase. Right? Okay. I told you how it is inversely, hai na? Very good. Inversely proportional. Now, ma'am, what about alpha? This is the last graph, so see this very carefully, right? Okay. Alpha is the amount. I have told you about alpha in the first order, in the zero order reaction. I have told you about alpha. Let me see how many of you can remember what is alpha, right? What is alpha? How many of you can remember what is alpha? Alpha is nothing but alpha is equals to number of moles that is dissociated. Dissociated, how many moles were dissociated? X amount was dissociated, divided by the initial moles, that is A naught. And X is nothing but it is A, we know that AT is equals to this. So here we can say that X is equals to A naught minus AT. So can I say that this is A naught minus AT by A naught? So can I write alpha is equals to nothing if I divide this 1 minus AT minus A naught? Alpha is nothing but 1 minus AT minus A naught. 1 minus AT by A naught, that value. So I just need to find it out. Now you just need to tell me what was the value. Can you see? 80, wait a minute. X, this is 1 minus AT by A naught. Yes. So if you see this 80 is equals to, or you can see this also here. If you see this, from here also we can find the value easily. I have done all that. From here also we could easily have we could have find it that out, right? So here it is. Alpha is 1 minus AT by A naught. Now we also know that alpha is equals to x by A naught. So can I say from here x by A naught is equals to 1 minus e raised to power minus kt, and x by A naught is alpha. So can I use this formula here? Alpha is equals to same formula, same formula we have written here. Alpha is equals to 1 minus kt, right? Okay. Now, if you see this here, if time increases, this minus kt will decrease. That means this value will also decrease. That means this whole value will increase, right? So can I say that as time increases, alpha also increases. Better see, if this is time increases, minus of kt will decrease. That means e raised to power minus of kt will decrease. That means e raised to power minus kt will increase. So that's why as time increases, the value of alpha also increases. That's why it is a positive exponential here. Okay. Yes. Now tell me how many of you are able to understand this, right? Okay. This Kamolika is even villain. It's even more, I feel the villain vibes from this Kamolika than Kamolika from the Sauti Zindagi Ki. Isn't it? So Monica, you are here to chit chat. Now girls are giving tough competition to boys, is it? Girls are like, boys are also free and they also chat on YouTube chats. So we will also be like full empowerment will be there. Which are these kind of empowerment women don't need, right? Okay. So if you're a guy from a girl's ID, right, then we can't do anything about it. But if we wanted boys, right, to follow a right path, right, to respect girls. But here I can see girls are also following the same path. Like, ma'am, we will do this kind of empowerment. That's what I never expected. Na? Girls, when we were like kids, na, they was thinking, okay, boys are like very shararti, boys are always like doing time pass, girls are very sincere. Now, girls be like, we'll also do time pass. Full empowerment we will give to boys, right? Is it the empowerment? No, right? To all the girls out there, one very important thing, huh? Uh, why we talk about women empowerment? Why we talk about men of the house, right? They also have so many responsibilities on them. Every single guy who is out there who wants to crack JEE, why? Because they want to land up in a good college, they want to have good package so that they are financially secure for their family, they can fulfill their dreams because they have seen their fathers doing that, right? And what about women? Why they want to like get into IITs and have a good package? Why? Because they have seen, right? If their mothers usually at this age, like most of the women were like housewives only, right? Back then, because we have seen that when women are housewives, right, the respect from the society is less. That's a sad reality. A housemaker is 24 and 7 job, but we don't give any credit to that. That's why your parents, your mom always pressurize you. Please study, please. This is for all the girls out there. Why you're being so pressurized? You always think that, oh, I'll marry some rich guy. What you would do by marrying a rich guy? You'll ask for money to them. I know you will feel like I am taking care of their house, I can ask for the money, but will that man respect you for that? They should, but do they have that much sense or that much good education or that much good, uh, like less patriarchy in their mind? Or tell me one thing, right? If you have to earn yourself, you have some like burden in your family, like you have to support your family, you have not done anything in your life, you have just done time pass, will you be able to do that? Understand one thing, when a guy, a man, he's not earning, he don't get respect in his family from his like his wife and kids also. Why? Because he is supposed to hold that responsibility, right? But right now, if a woman is not earning, she will also not get that respect because she is not empowered enough, right? So that is the truth about our society that we are moving towards. So please study. Nobody is going to give you any this relief, right? So please study. Ma'am, gain my respect, or I also respect you because you always study, right? Okay. So this I'm telling all of you this because even if one student is able to understand now, uh, that would be great. Trust me, it's very important to earn. And to earn something, you need to like do something in life. You need to have some skills, right? And for that only, we want you to land up in good college, right? Okay. It's not like in job you will do these questions, but to get into that job, you need to get into a good college. For that, you need to do this. That's not me, that's our education system. So I can't do anything. They need to check your capability. So that's how they will check. Okay, right? Struggle day and out. For me, I can't and never let them down. My father says he will continue the hard work for next 10 years if I would be successful. See, see, Bharat, Parents are like that, right? Parents do so many sacrifices for you. I want you guys to land up into a good college, to have a good package at the age of 21, so that you retire your parents, right? It's the best feeling in the world when you can say, Papa, Mama, you can relax because your son, your daughter, it used to be son, but now it's daughters also. Your daughter is earning, your son is earning for you. Just relax. You don't need to sacrifice. They have never gone to any good trip, international trip. It's not like they don't have money. They have money, but they are investing that money for your education. If they don't invest, they put you in some random school or something, they would have gone to a good trip, right? Isn't it? But they're not doing all these things. They're investing for your college fees, for your school fees, everything they are doing. So respect that and please don't do time pass. Okay, chal. So much of lecture I have given you, right? So let's talk about the question here. Integrated rate law equation for first order gas phase is given by, now students, JEE means 2024 question. This is, we are talking about the gas phase here. So let's talk about a general reaction of first order reaction. This is a general reaction. When nothing is given, we'll take a general reaction. Okay. So now let's see this. We are saying that at time is equals to 0. Initial is Pi, then product are 0, 0 at, like when time is 0, there is no product when time is 0. Only initial pressure. In for gases, it is not concentration, it is pressure. So it is the initial pressure, that is Pi, right? When I talk about that time is equals to T, in that case, how much amount of pressure is consumed, that is X amount. If this is 1, this is 1, this is 1, so by stoichiometry, X amount will be formed and here also X amount will be formed, right? And we know that in the formula of equation here, K is equals to 2.33 by T log of P naught by Pi, that is the, sorry, P naught by not Pi, P naught by Pt, that is the final pressure. This is nothing but this is Pt. Pt is equals to Pi minus X. Now you have to tell what is Pi minus X in this form, right? What is Pi minus X? This you have to tell, right? Now students, see, one thing is that Pt is equals to Pi plus X. This, can I say that Pt is equals to Pi, sorry, Pt is equals to Pi minus X, it should be, right? Wait a minute. Total, total. Yes, this also you should know that if you see the total pressure here, right? Total pressure is equals to Pi minus X plus X plus X. So can I say that Pt is equals to total pressure is equals to Pi plus X. Total pressure is equals to Pi plus X. That is the total pressure. Okay, that is the total pressure, that is Pt is equals to Pi plus X because of the total pressure. See, in that beaker, total pressure is of this gas and this gas. That is coming out to be Pi plus X. You have to find out the value of Pt not in terms of Pi, not in terms of X. So how will you find it out? I'll just write it here. We can write that Pt is equals to Pi minus X, and we also know that X is equals to, can I just write it here? X is equals to Pt minus Pi. So I'll just put it here. X is equals to Pt minus Pi. Pt minus Pi. Oops, silly mistakes I am doing. Pt minus Pi, na? Pt minus Pi. So if this is minus, if you solve it, Pi minus Pt plus of Pi. So this will become 2 of Pi minus Pt, right? So that will be the value of P. That will be the value of Pi minus X in terms of Pt. Okay. Ma'am, it's so confusing. Please explain again. Chalo, yaar. Let's do this again. See, I'll explain this again. Where should I explain this? So I'm explaining it here. Wait a minute, huh? I'm just explaining this. Whenever I write like this, now I know you never understand that. Okay, so I'll just write it myself. See, we know that this is the equation. So this also I'll write it myself. Okay. This is the equation that we are assuming, right? Now, initially I'm saying that it is Pi, this is 0 and this is 0. At time t, this is Pt. Now, Pt is nothing but Pi, you subtract x from here. If x is subtracted, x is formed, right? Now, tell me, what is the total pressure of these gases? So, here they have given you Pt as a total pressure. Pt is the total pressure that they have given. Pt is the total pressure at time t, right? Okay, Pt is the total pressure at time t, right? Now, I am assuming this to be P capital D. I am just writing this as P capital T here, okay? I'll replace it, but right now I am writing this as P capital T, okay? Or I would advise you not to mention anything here, right? Okay, one more thing I can advise you here, which will be less confusing. I think you are getting confused between PT and PT, right? So what you can do here, just write it down, Pi minus X amount, this is X and this is X. Till here things are clear to you, right? X amount is being produced here for B and X amount is produced for C and X amount is taken for A, right? That is how stoichiometry works, right? Now, we know that total pressure, they are saying that in that beaker, the total pressure is PT. That is PT, total pressure. So, PT is equals to total pressure, that is Pi minus X plus X plus X. When you solve this, this will become Pi plus X. Can I say Pi is equals to nothing but PT is equals to nothing but Pi plus X, because PT is given to be the total pressure. Okay. Now, if you want to solve this question here, that is, they are asking you which thing? Wait a minute. They are asking you what is the integrated rate law, right? So, we know that that is K is equals to 2.303 by T. So, you can also write it like this. Log of initial concentration by final. Initial is Pi. Final is Pi minus X, okay, is equals to Kt by 2.303, okay. Now, see, answer, I can't give it in the assumed value. X, I have assumed that X amount is being taken out. So, I have to give the answer in the values that are given in the question, okay. I have to give the answer in the values that are given in the question. So, they have not given, they have given Pi is initial, PT is total pressure at time t. So, I have to give the answer also in Pi and PT. So, how I will solve this, right? We know that PT is equals to Pi minus X. So, can I just write down the value of X here? X will be equals to PT minus Pi, right? That is the value of X. Now, if I put Pi minus X is nothing but Pi minus of X is given to be PT minus Pi, right? So, this will be a Pi minus PT. This is nothing but this is plus of Pi, because minus minus will become plus. So, this will be 2 of Pi minus PT. This is your Pi minus X. So, can I just put this value here? That will be, I can just solve the value of K here. K is nothing but 2.303 divided by 2.303 divided by T log of Pi divided by Pi minus x is nothing but 2 of Pi minus Pt. So that is going to be the answer. So answer will be 2 Pi minus Pt, 2 Pi minus Pt. So answer will be first is the correct answer. Okay, answer will be first is, it's initial by final, okay? It's not final by initial. If you say log of 80 by final by initial, if you are doing, right, then it has to be positive there. Okay. See this formula that you should like keep in mind. If that is, wait a minute, where it is initial by final, then it is positive. If you're doing final by initial, then it has to be negative. Okay, that you have to remember. Okay. Okay, perfect. Very good. Now what we have is, this is done, this is also done. I think, yes. Now let's talk about the next question here, right? In the end, I am going to tell you a very, very important concept regarding first order reaction, okay? So I already told you that this lecture is going to be lengthy, right? That's why I told you that have your dinner before the class, right? Okay. Okay. Let's do this. Let's do the next one here. This is valid for first order reaction. Now these are two statements are given to you. Statement one is, this is valid for first order reaction. So for first order reaction, T half is independent or dependent? For first order reaction, T half is independent. T half is equals to 693 divided by K. It is independent. So that is correct. What about the statement 2? This is valid for first order reaction. We know that, if you remember this, we know that log of initial by final. This is final by initial. Final by initial, and that to log, if you see this here, that will be log of initial by final is equals to Kt by 2.303. Okay? So that means log of A naught, you can write it as log of A naught minus log of At will be this. So I can write the value of log of At by A naught will be opposite, you put it here minus. So that will be log of At by A naught. That is the formula that I have already told you that you need to remember that, right? Okay, you can also generate from here. Plus minus only I am doing. It's very easy for math students, right? So we know that if you see this here, log of At by A naught is minus of this. If you compare this, if this is your y, this is x, then the slope is minus of k by 2.303, which is coming out to be negative. So it should be like this, right? Okay, but it is not like this, right? So that means it is wrong, right? That means it is wrong. It should be like this. It should start from 0 and it should be like this. Okay, that should be the correct answer. So that means this is not right. So statement 1 is true, statement B is false. B is the correct answer here. Very good, right? Okay, B is the correct answer here. So the slope has to be decreasing. But one thing, wait a minute. One thing also you should remember, this will not start from here. It will start from here. Okay, because the intercept is 0, it will be like this. Okay, intercept is 0, so it will be like this. Okay, everybody. Okay, everybody. Intercept is 0. That you should remember. Next question is, the initial concentration of N2O5 in the first order reaction is this. The concentration of N2O5 after 70 minutes is this. Okay, let's see how many questions. 2 more questions, right? And then some 2 more concepts and we'll be done, right? Now, see this. The initial concentration of N2O5 in the first order reaction is this. was this. Initial concentration is this. Okay, this is the initial concentration A naught. At this, the concentration of N2O5 after 60 minutes is this. That means this is 80. Calculate the rate constant for the reaction. So simple is, we know that log of, or you can just solve it like this, log of initial concentration by final concentration is equals to Kt by 2.303. Okay, so they are asking you to calculate the rate constant, so it will be multiplied by 2.303 divided by T, that is the value of K, right? This you have to do, right? So I'll just place it here. K is equals to this, right? So time is given to be 60, and that's why the answer of K will be in per minute, because this is given in per minute. Okay, this is given in minutes, so answer of K will also be in minutes, right? So if you, that depends on the options, whether it's given in seconds, minute or hours, right? For that accordingly you will answer, right? 2.303, I'm just solving it in minutes only, so I'll putting it 60. This is log base 10. A naught is given to be 1.24 into 10 raised per minus 2 divided by 0.20 into 10 raised per minus 2. Minus 2 will cancel. Now students, what is the most important thing to solve the value of log here? Okay, so I'll tell you how to solve the value of log, right? I have already told you that how to learn the values of log. So this is log of 1.24 divided by 0.20. Point will cancel, so this will be 124 divided by 20, right? Okay, so this will be 210,262, right? That will be 6.2. Log of 6.2 you have to solve. See, log of 6 is equals to 0.7, right? So 6.2 will also be equal to 0.7 something. This is equal to 0.77. So you can take it as 0.7, 0.8, you can take it as 0.78, you can take it as, I'll take it as 0.7, right? Approximately it is 0.7. Okay. So put the value of this here, this value you will put it as 0.78, you can put, right? Little bit more it will be. So 0.78 you can put, you will get the value here by solving this, right? Okay. Yes. Ma'am, better we take it as log 6. Yes, you take it as 0.77. Great. Okay. So solve this and you will get your answer, that is 0.0304. In minutes you will get the answer per minute. Okay. Understood? Now, one very important concept of first order reaction, right, that I am going to tell you here, that you should definitely know, that is, see, you will use this formula, that is log of A naught by AT is equals to KT by 2.303 for your numericals. Now the question is, what you will use AT and A naught if the specific values are not given. Now what you will do here, see this, if you take, very important, if let's say things are given in percentage, things are given in percentage. Percentage means they have given you 10% of it is consumed, 20% of it is consumed, 30% of it is consumed, right? Then what you have to do, right? So let's see that here. If things are given in fraction, that's what you have to take. Okay. So when things are given in percentage, you will take initial as 100 and you will take final as 100 minus the amount of percentage that you have already consumed, right? But in case of fraction, you will take initial as 1 and final as 80 will be equals to 1 minus x, whatever x is given in fraction. Let's say they have given 60% is consumed, so initial will be 100 and final 60% is consumed, so amount that is left is 100 minus 60, that is 40% will be your 80. This is about consumed. If they are saying that the amount that is left behind is, they can say that 60% is left behind. Okay. then you say 60% is equals to 80. So that is the language English, right? So not a big deal in that. Let's say here they are saying that 1 by 4 is consumed. So A1, A0 will be 1 and 80 will be equals to 1 minus 1 by 4. So always remember, when things are given in percentage, you will take A0 as 100. When things are given in fraction, you will take A0 as 1. Okay, that will be very, very useful for you. Okay. Yes, everybody. Now, let us solve this question here, right? Now, let us solve this question here that says, for rate constant of first order reaction, right? Now, they have given you rate constant of first order reaction is 60 per second. See, what we have is, okay, log of A0 by 80 is equals to KT by 2.303, right? Now see this thing very carefully. Rate constant is given like this, right? Now how this is the website, it is mentioned first order, otherwise the rate constant units are defining that it is first order reaction, K is equals to 60. How much time you have to calculate to reduce the initial concentration of reactant to its 1 by 6th value, that 1 by 16th value. That means the initial concentration of the reactant is reduced to its 1 by 16th value, right? So that means 1 by 16th value is the initial concentration. So if I take here E0 as 1 and 80 as 1 by 60, okay, then I'll get the answer. So I can put log of A0 is 1, this is 1 by 16, this is KT, what is K? K is given to be 60, this is time, this is 2.303, 16 is nothing but 4 square, so we can write it as 2 log of 4, or you can also write it as log of 2 into 2 into 2 into 2. 2 raised to power 4, right? You can write it as 2 raised to power 4 because 2 into 2 into 2 into 2. 2 to 4, 4 to 8, 8 to 16, right? So you can write it like this. So it can be written as 60. You can take it here and this will be multiplied by 2.303. That is your T. And you can solve it like this. You can solve it like this. T will be equals to 2.303 divided by 60. 4 multiplied by 4 into log of 2. Log of 2 is nothing but 0.301. So you just put the value here, 2.303 divided by 60 multiplied by 4 multiplied by 0.301 and you will get your answer for time, and that too in seconds. Okay, and that too in seconds. Okay, time will be in seconds beta, not per second, otherwise you are on the right track, right? Okay, yes. So while solving you will get your answer and that will be in this, right? Here they have taken it as A, so that's why I have given you a direct answer that fraction you take A0 as 1 and 80 as whatever is given to you, right? Okay, solving this you will get your answer. Now let's see pseudo first order reaction. Okay, tell me what is pseudo? Anybody in the chat box, what is pseudo? What is pseudo? What is pseudo, guys? Everybody. Yes, everyone. What is pseudo? Fake? Yes. Pseudo means not true. Okay? Pseudo means not true. Right? Something that is not true. Pseudo, false. Right? So, yes. But not actual. Pseudo appears to be real or real like, but it is not real. Right? So pseudo, so it is appearing, so what is pseudo? Reaction in which kinetics of the reaction is studied by decreased order are known as pseudo first order reaction. So example is, that if you see this reaction, right, in this case, because H2O is in excess, so if you see this, right, it does depend on H2O, but because H2O is in excess, that's why it will not depend upon the excess reagent, excess reactant. So any particular reactant is in excess, then that is a pseudo first order reaction, right? So hence R is equals to K dash CH3CONA. First is pseudo first order reaction, that is hydrolysis, that is appearing to be first order reaction, right? Okay, so when one of the reaction is reactant is in excess, that appears to be a pseudo first order reaction. Second example is inversion of cane sugar, that also you will study in biomolecules. That is also a pseudo first order reaction. Rate law equation involves catalyst, right? Because in this, the catalyst is involved in the rate law equation. That is also a pseudo first order reaction. Okay? Okay, everybody? Any problem? Any problem? But a pseudo is that is giving an illusion, right? But in reality, it is not, right? Why it is not clear? Wait a minute. Why it is not clear, students? Let me know why it is not clear. Everybody. Pseudo first not clear. Okay, ma'am. Tell me, beta, which thing is not clear to you? See, simple is that pseudo means false, right? Something which appears that, okay, this appears that it is a first order reaction, but actually it is not a first order reaction. Actually, it's a higher order reaction, but that is in the experiment also it is appearing to be a first order reaction, but in reality it is not a first order reaction. For example, you have hydrolysis, right? When any reactant is in excess, then what, because of the excess reagent, with the change of the excess reagent, there is no change in the rate. That's why it is appearing to be a first order reaction, but in reality it is not a first order reaction, right? Similarly, if you involve catalyst is involved in the rate law equation, then also it is appearing to be a first order reaction, but in reality it is not a first order reaction, right? Okay, okay, now it is clear. Now it is clear, which is actually of higher order, but to us it is appearing to be a first order reaction. Okay, because of certain things like one of the reactant is in excess, or you see like there is catalyst involved in the rate law equation, in those cases, right? Now it is clear, everybody? Okay, means excess is not affecting the rate of not pseudo. So it's pseudo, ma'am. No, it's like in the rate law equation, it should be all the reactant should be there, but sometimes what happens, some of the reactants in excess, that's why it appears to be first order reaction, but in reality it is of higher order, right? But one of the reactant which is in excess, that we are not able to predict that if there is some change with it, but in reality it is higher order reaction which is appearing to be a first order reaction, right? Something which is like, to us it is first order reaction because experimental data is showing that, but in reality it is not a first order reaction, it is of higher order reaction. Okay, yes, okay. Last topic of today, guys. Last topic, I think. Yes, last topic here. Yes. Okay. This is very, very important, right? This is a very, very important thing. So if you remember, I taught you this in zero order reaction, right? I taught you today in zero order reaction. What I taught you, that if you see this is A naught, right? after 1/2 life, right, it will be A naught by 2. After another half life, it will be completed. That means it will be completed. That means, can I say that T 100% is going to be 2 into T half? T 100% is going to be 2 into T half. Can I say that for a zero order reaction? Right? This is what I told you about a zero order reaction. Tell me if that is clear to all of you or not. Tell me, students, if that is clear to all of you or not. Now, see the next thing. But if you talk about first order reaction, this is very, very important, and based on this in your JEE Mains, JEE Advanced questions are asked. Very important, this is very important. Okay, see this very carefully. If this is A naught, right, initially it is A naught. After T half, it will be A naught by 2. But after one more T half, things will change here. See, in zero order reaction, T half is dependent on the initial concentration. T half is dependent on the initial concentration. That's why if you see this T half, if you have another T half that was dependent on this initial concentration, right? That's why T 100 is 2 into T half. But that will not be the same in first order reaction, because first order reaction T half is independent of initial concentration. It does not depend on the initial concentration. So now let's see what will happen, right? So see this thing, very, very important. What is going to happen in this case? Remember that T half will be equals to A naught divided by, this is very important, that after T half, I'm not saying T half is independent in the first order, but something is there, some relation. So what is the relation? That it's not T half, it should be A T will be equals to A naught by 2 raised to power n. N is the number of half-life. Let's see what exactly do we mean by this thing, right? Okay. After T half, what will happen here? This will be A naught by 2 raised to power 1, because T half is only 1, because only one half life we have used now. Okay. After one more T half, let's say you have one more T half. Okay, one more T half, because it is not dependent on the initial concentration. How it is? This is A naught by 2 raised to power 2. So it will be A naught by 2 raised to power 2. That is nothing but A naught by 4. Okay. After one more T half, what is happening? This is equals to, see, this is very, very important. A naught by 2 raised to power 3, that is nothing but A naught by 8. After one more T half, what is happening? Right? A naught by 2 raised to power, how many T half? 1, 2, 3, 4. 4 T half, it will be 4. So it will be 16. After one more T half, what is happening? After one more T half, what is happening? It is A naught by 2 raised to power 5. 16 into 2, 32. So it will be A naught by 32. After one more T half, what is happening? Do you want me to write it? Wow, awesome, right? Wait a minute. Do you want me to write one more T half? After one more T half, what is happening? It is A naught by 2 raised to power 6. 32 into 2, that is 64. It is never completion on completion. You know what is happening here exactly? In zero order reaction, what is happening? A naught after one T half, let's say T half is 60 minutes. So after 120 minutes, full thing will be completed. Full reaction will be completed, right? Full reaction in zero order reaction. Let's say T half is 20 minutes. So after 40 minutes, full reaction will be completed. Because in first T half, it is A naught by 2. In second T half, 2 T halves, it is completed in zero order reaction. Is that clear? Right? Okay. Yes, Bharat, it will continue till infinity. But in first order reaction, this in zero order reaction, it will be completed. But in first order reaction, what will happen? Firstly, T half is A naught by 2. Then what is happening? It is always going half, 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 half. Right? Half of this is half of this is half of this is half of this thing, this is half of this thing, this is half of this thing. Okay, that means in general you can learn this formula. Now here what we have learned, that very important thing. Firstly, tell me till here if this thing is clear to everybody or not. Till here if this thing is clear to everybody or not, let me know. Right now, here 50% of the reaction is completed. After 50%, can you see, let's say T half is 20 minutes, right? Then after 40 minutes, it will be A naught by 4, right? So that means how much percentage is completed here? Can you tell me? Initially, it is A naught. You have completed A naught by 4. This much is consumed. This is the amount, that is, you have consumed the amount, right? So that means you're left with 3 A naught by 4. That is nothing but 75%. That means, can I say this? This is defining 50%. This is defining half. Very, very important, beta. Very, very important. This is 50%. This is defining half of this. That is from here to here. Here to here, it is nothing but half of this. That is 25%. This is defining half of this. That is 12.5%. This is defining half of this. That is 6.25%. Right? This is defining half of this. After one more half life, it will be 3.25. 6.25 half is what? 6.25 half is what? Wait a minute. Let me just see that. 3.65, 3.65 or what? 25. Arey yaar. 6.25 divided by 2 is nothing but 3.125. 3.125. Then division of this by 2, it is 1.5625. Okay, don't worry, this much they will not ask you. I just want to tell you, it will never end to completion. First order reaction is never completed. It will complete to 99.999%, but not 100%. Right? Okay. So that's why the examples are radioactive decay. Right? They never end. There is no 100% completion. Decomposition of H2O2, decomposition of N2O5. Then you have ethylene, hydrolysis of ethylene. Okay, all these examples are there. Right? Now, bacha, if you see, if I put a mark here, this is 50, this is nothing but 75%. You add these two things. From initial, it is nothing but, what about this? From this to this, you have consumed 3 T half-lives. So that is 75% plus 12.5, that is 80, 75, 75 plus 12.5, that is 87.5, right? Till here to here, plus 6.25, 6.25, it is 93.75. Okay? Percent from initial. Okay? Now, from this data, I will write, ma'am, then what do you consider its negligible means at the power of 2? Then what do we consider its negligible means at power? I didn't get your question. Can you explain that? I didn't get your question, Bharat. Okay. So now, can I say that this 75% is nothing but when T is 75%, that is nothing but you are using 2 half-lives. T 85%, you are using how many half-lives? 1, 2, 3. 3 half-lives. At 93.75%, you are using how many? 1, 2, 3, 4 half-lives. Right? Shall I add more? Shall I add more? Okay, I will add more. Okay, if you use this thing, I have told you about 3 here. If you use this thing, okay, let's see if you talk about from initial to this one or this one. Okay, this much वैसे they will not ask you, I'm just telling you this, right? Any question from this data, if you're able to do this thing, na, you don't have to cram this. I have not crammed myself, so why will I tell you to cram this, right? So if you know this, like how to do this, if you know this formula, you can easily form any formula, right? So this is the uh, till here it was 93.75. Okay, you just need to do additions here. 93 point plus what amount is being added? 3.125 you need to add, so that will be 96. So you can just write it here, T of 96.87, that is equals to nothing but 1, 2, 3, 4, 5 T halves. Okay, 5 T half. Now, next is if here you add 1.5625, then it will be 98. So you can say 98.43 is equals to 6 T half. Right? Similarly, you will have 7 T half, 8 T half, and so on. Okay, everybody? Yes, students, let me know. Now, you need to tell me one very, very important thing, that is T. It's not you need to tell me, but this is actually the formula. After using this, like when applying this, so on, you will see that T 99.9% is nothing but 10 of T half, and this is a very important formula. This is directly used in your JEE, right? This formula is very important. This formula is very important, that is usually used. This one is very important. So 1, 2 and this third, this one is very important. Otherwise, you should know how to make these formulas by yourself also. Okay? Yes, everybody? Okay, at power of 2, do we consider that reaction is almost completed, ma'am? No, we don't assume that. Right? We never assume reaction is always completed. Right? It is never completed. Okay? It is up to infinity. It is completed till 99.9, then 999999. It is never like fully completed. Some fraction will be left only. Right? Okay? It will keep on decreasing. Right? Okay? Yes? Very good. And that's it. Now, this is a formula directly of second order reaction. Right? That is 1 by AT is equals to KT plus 1 by A naught. This is the initial concentration. Because second order reaction is not that important for you. This is final concentration. That's it. Okay? Yes, everybody? And that's it. Now in the next class, we are going to do nth order reaction. I will give you some general formulas, right? We are going to talk about average time period. We are going to talk about collision theory, Arrhenius equation, all these things we will talk about. How order or rate constant changes with increase in the temperature dependence, catalyst dependence, Arrhenius equation, activation energy. All these things we are going to talk about in the next lecture, and that is going to be the final and last lecture of chemical kinetics. Okay, students, right? One more lecture of chemical kinetics and your session will be done, right? Okay, students? Yes. So that's it. Till then, bye-bye. Take care. And students, don't forget to do your homework here. This is the first question here for your homework. Take the screenshot. This is the second question for your homework. Take the screenshot of both the questions here, right? Let us see how many of you give the answers in the comment section. And this is our official Telegram channel. And for all the students who are like, ma'am, we want to enroll into a batch where, ma'am, you guys are teaching, then definitely, students, we have this for you. That is your Sigma JEE 2026 batch that is specially designed for JEE 2026 aspirants, right? You can see here live classes are being taken by your teachers, right? Your master teachers are there, right? I am there, Shreyas sir is there, Namrata ma'am is there, right? And students, in this particular batch, we provide you mock tests. We provide you, like, after every 15 days, mock tests are being taken, doubt sessions, doubt classes are being taken in the classes, quizzes are taken, leaderboards where you can see your competition, and in mock tests also you will be provided with the analysis. You are provided with the QR cards also that I want to show you, right? QR cards, like these kind of QR cards are shown, are given to you in the batch itself. Then Tattva modules are provided to you, right? Test series are provided to you. That's like part syllabus, full syllabus tests are provided. Tattva modules will be provided to you, soft copy and the hard copy as well. You can view the course plan here. So at 3999, you will have the Sigma batch. If you want to have quick JEE revision cards as well, that is like these kind of cards if you want to have, then that will be for your 4999 along with the Sigma batch, right? So you just have to pay 1000 extra to get these cards. And if you want to get Tattva modules in the hard copy version, right, that means what you will have to pay is 7999. Now, in this and this batch, modules will be provided, but in the PDF form, right? Here it will be provided in the book form, right? Hard copy form. Okay, so that's totally choice what you want to opt for, right? Okay. Okay then, students, thank you. Thank you, Nirmal, getting admission to good college. Okay, thank you. I got all the questions based on your previous year question. Thank you so much. Thank you so much, Nirmal. Then please write it down in the comment section as well. Refer this video for your juniors as well. Thank you, Rama Raju. Thank you, Future IIT. Now, I want all the students here to do their homework. Right? Okay, this was the first live of yours. Thank you so much. Wonderful class. Ma'am, I almost started crying. Lots of love. Oh, that's so sweet. That's so sweet. Thank you, beta. Thank you, Bharat. Thank you so much. Now, I want this same comments to write it down in the comment section. This makes me so happy because chats will go, but your comments will not go. Right? So, I want you guys to write it down in the comment section as well. That makes me so happy. And, I feel motivated to do more hard work for you guys. Right? Okay? So, write it down in the comment section as well and do your homework also. Right? If you respect me, then do your homework. Right? Okay? Yes. Okay then. Bye-bye. Take care. See you all in the next class. Bye-bye.